research, mainly because climbing trees is quite exciting. But once you start to do that, you realise quite how dynamic trees are as entities, but they're entities that do fail, and they adapt to the environment in the short term and also in the long term.
The mapping of the sound, you'll be showing the topography of the landscape itself, and being able to actually click on the sounds to listen to them.
Sound passes through water. The fish moves at the same rate as the sound. If you have a heavy bone inside your head, the movement rate of that bone is different to the movement of the fish in the water. And what they do is to pick up on that difference.
Otoliths, now the actual inner ear bones of fish.
And being able to understand and monitor the health and the behaviour of those trees, potentially remotely, would be extremely valuable ecologically, potentially artistically.
To be able to listen out for particular sounds by using a stethoscope. It's non-invasive, and again, you're analysing a wealth of information.
The scientific community didn't have anywhere to use advanced microphone techniques such as ambisonic, which use 3 or 4 microphones in a very compact array, to attach it onto these gyroscopic and geometric, whatever stuff the guys use, to give us some idea of what these guys are listening to.
It's not unrealistic to actually be able to strap some microphones on an animal and be able to record that information.
Becoming a more visually oriented culture.
To Nick, an idea that was presented this morning, that it might be actually quite interesting to map the oceans using this technology as well.
What's wrong with the engine? Well, maybe one of the first things we do is get a screwdriver to his ear and actually put that to the engine and be able to diagnose a problem by listening.
When you get forward motion, it pulls you through the water.
Empirical evidence on one hand and artistic evidence